Take here. Okay, so let's start with this. Who's number one? All right. So just name, talk title, and then if you please could keep it within 5 minutes, we will definitely finish on time. All right.
Hi, everybody. Thanks again for the talk. That was really great. So my presentation today is going to be large language models meet the elevator industry, and I'm Mark. As far as the problem goes and why I started working on this project, one of my friends in the elevator industry, he is an elevator consultant, which I didn't even know existed, but he has to be an expert on a bunch of really technical machines. And so each machine has hundreds of pages of documentation. So rather than look up the documentation, go to engineering, then go to this person and this person, wait 2 days and get an answer for a customer, he can use this tool that I created for him to get the answer instantly. So what is the solution? How's it work? So this is just a simple GUI that I made. It's a chatbot. He can talk about any of the machines that he has to be an expert on. This is all using like LangChain, OpenAI embeddings and things. But there's two things that I think are kind of cool about this solution that I thought would be fun to share. So we all talked about this idea of explainability and how do you know if the answer is BS or not. If you can, hopefully you can see pretty well, but as part of this solution, we have in the bottom right, those buttons, they're ranked in order of like where we think the answer came from. So if you see the very last question, it says, what type of grease should I use? And it says the lithium-based CP2. And if you can read under grease type, that's exactly what it is. And so that does it for every question, and it points you right to where the answer came from. Now, there was a problem that I came across, which was specifically surrounding tables. So the large language models don't really interpret table text very well, especially not structuring it well. So I created this algorithm that uses basic document AI algorithms to take the table, and then at the bottom is basically the output. And I input this into the document over the table so that there's no confusion. And then in plain language, the table is able to be interpreted. So all that is to say, it's a pretty basic stack. GPT embeddings, ChatGPT API, LangChain, document layout models like Layout LM, if you've ever heard of that before, and then some table layout models that are basically taking the structure of the table and interpreting it into something that I can parse. That's my quick little project that I'm working on. Hopefully you thought it's kind of cool. If you did, I'd love to hear your thoughts on it afterwards. Shoot me a message, whatever. But yeah, thanks for paying attention.
Hello, can you see my screen? Okay, sweet. So how familiar is everyone with Databricks? Oh, okay, seems like a fair amount. I'm just gonna do like a very quick overview to familiarize yourself and then show an example of Dolly, which was mentioned earlier, is our large language model that we recently released. But to start off, Databricks is the Lakehouse platform. It's a data and AI platform. It kind of takes the best of a data warehouse and a data lake. So as you may know, data warehouses were first created to kind of support structured data files, but not really created for unstructured data files. So things like text, which is relevant to today's discussion, things like videos or images weren't really supported in data warehouses, but they were able to do a lot of large processing. So that's where data lakes kind of came out of formation to process unstructured data files. So again, things like text, images, and videos. But the thing is that those two systems were never really created to communicate together. So you had a data warehouse for kind of your BI, and then you had a data lake for your AI, but you had two separate copies of data. You had two separate governance models on those stacks. And so it became convoluted. It created silos that we saw within the industry and didn't foster collaboration. And so that's where Databricks came in and said, let's create what we coined a lake house, which brings the best of a data warehouse and a data lake under one roof. So you're able to support all different types of data files, whether they're structured or unstructured or semi-structured. They sit within your cloud storage. So you can see that is at the bottom there. So we sit on top of Azure, AWS, or GCP. And then on top of that, everything on top of this cloud data lake is Databricks. So the Delta Lake is like a transactional layer that just sits on top of your data lake, and that brings reliability and performance to your data through ACID transactions and things like you can time travel because you get a transaction log. So any sort of operation that's ever done on your table is logged. And then you can query the previous version of that table via the version number or date timestamp. So it really fosters like a single source of truth for your data. On top of the Delta Lake, we have our Unity catalog feature, which is our fine-grained governance. So again, this bridges the gap between the two legacy systems of a data warehouse and a data lake. Now we just have one layer of governance for all of that. And it's not just any of your tables, it's any sort of data and AI product, right? So it can be dashboards, it can be your ML models that you create, et cetera. And it goes down to the row and column level, which is nice and also supports lineage. And then on top of that, you'll see kind of like the different personas we cater to, which are data engineers, data scientists, and data analysts, again, sitting all under one roof. So that's kind of a very quick introduction to Databricks. Has anyone heard of Spark, Apache Spark? Okay, so our co-founders they were like 6 PhD computer scientists at Berkeley. They created Apache Spark, they open sourced it. And then they saw a lot of adoption among the community of the product they created. And investors pretty much kind of started coming and saying, you should commercialize this, make some money off of it. And that's kind of how Databricks formed. However, we've kept that open sourced, strategy throughout Databricks lives. So the most recent being Dolly, which is open sourced. So actually I forgot to do this. Let me look it up very quickly. So yeah, like I said, we continuously to create products and open source them because our mission is to democratize data and AI. So the first one being Apache Spark. We've also created ML Flow, which is the machine learning lifecycle management system. That's open source. Our Delta Lake is open source. And now Dolly is also open sourced. So as you can see, you can quickly go to our GitHub page and start playing around with it. Download everything you need for it and start playing around. So as opposed to ChatGPT, when you type in a question, you receive a response and you have no idea how that response was generated. It's a black box. Here with Databricks, the purpose of Dolly was to kind of create a glass box so you have a better understanding of how this output was generated, and you can also fine tune it to your liking and specific use case. And that's exactly what this notebook goes through. So this is a demonstration of Dolly being augmented with data around healthcare and life sciences. I'm a solutions architect within the healthcare and life sciences for Databricks, focusing on payers and providers. So this is a demonstration that's relevant kind of to that area. But so what we do here is basically download some PDF files from PubMed, a public source around cystic fibrosis. And so, this is just to show that you can, again, fine tune the Dolly model to a specific use case that is pertinent to you or your organization. So that's what we do here. Essentially, we go through a cluster setup. We prep some of the data. We create a database. And here you can actually see, some of the documents, the PDFs, and the text within the documents. And essentially, we tokenize that text and create a vector of sorts out of it, and then use that to augment, or, we've been talking about this, the LangChain, and use Hugging Face embeddings. We use this in conjunction to Dolly and then test it out with some simple question and answering. So for example, what are the primary drugs or treatments for cystic fibrosis? Then you receive an answer, but you also receive citations that were used to help generate that answer. So someone brought up the question before, like, how do you know, sorry, someone said, like a ChatGPT made up, oh, I went to this university and blah, blah, blah. But like, how do you even cite those sources? So this is a way to do that, which is helpful. And here's just another example. What are the cystic fibrosis drugs that modulate the CFTR protein? You receive a response. And again, the citations that were used to help generate that response. I know that I only had 5 minutes, so I probably already went over. To find out more information, again, you can go to, just type in GitHub, Databricks Dolly. You can download it. It's open source. You can see the training set that it was trained on, and start playing around. So thank you.
Great. This is kind of the other end of the spectrum. If that was relevant to work, this mic. Yeah, nice. Thanks. Yeah, a little bit of the other end of the spectrum. My friend Henry and I, so some of you used to work with Henry and me and Michelangelo at Civis Analytics. He had this idea, and it's Chicaghost. So the tagline is, "How long will my train delay last?" My friend Henry and I built this in a weekend at a coffee shop for fun. Henry was like, we should present at Michelangelo's LLM talk. And I was like, yeah, we totally should, thinking that he would do it. He's in Thailand right now, so I'm doing this. He did most of the science and a lot of the engineering for this. I did some front end work and doing this talk. So cool. The context is that like ghost trains really suck. If you've ever been on a CTA platform and it says like, it'll be here in a little bit, or oops, it's late, and then it just like never comes. This sucks for like us. I think a lot of us are like pretty well-moneyed tech professionals, but this like really, really sucks for people trying to get to like shift work. It's like a regressive problem. So we thought this was really lame. The technical problem, right, is like, can we predict the duration of a CTA train delay based on the alert text? And Keith, my former colleague, had a really good question when I came in and said I was doing this talk. He was like, yeah, like, did you have to use an LLM for this? Or like, is the LLM useful? And that's a really good question, right? But the truth is, I think, yes, it is, because it's all the data that we have. And I'll talk about that in like 1 second. All we have is unstructured text data on this. So not to make things any more complicated than they need to be, our data collection is just a GitHub action that pushes commits of alerts into a JSON file in our GitHub repo. Henry made this while we worked at Civis Analytics 3 years ago, started in 2019, and then like forgot about it. And so we had all this data a few weekends ago, and we were like, let's do it. And again, like, we didn't need a cloud hosted database. We didn't need an EC2 instance running anything, because it's just GitHub. It's just a file. And this file's like probably a few gigabytes now. We're like, fine. Yeah, this is what they look like. We just push them. And so this is, yeah, I should say a little bit about the data source. Sorry. I worked at Bain for a little bit and had to make really, really good slides. And now that I don't work there, I refuse to make good slides. So they're like kind of shitty, sorry. Hits the API every 5 minutes, cool. So this is actually a CTA hosted API, this top URL there. And so it gives us back this. It gives us an active alert, so just when it's active, and it gives us this short description. Yeah, the headline and the short description, full description. You'll see HTML coming through the API, because why the hell not? So we bring that into GitHub. We have it all there in the JSON file. And it never, there's no like authoritative data source of when these alerts end. It's just we mark it in this GitHub file as it's over because it disappeared. So all we really have is a start time, an end time, and a description. So that is my answer to like why the LLM is probably a useful way to do this, because we're not going to gather a bunch of other data about how many passengers were on it, et cetera, in a structured form. Git scraping, cool. This is the action. I'll share these slides. Great. So the model, we use this model that you mentioned before, a model family, the BERT model, with this auto model for sequence classification class method. And we give it 3 labels based on the alert, under 30 minutes, between 30 minutes and an hour, or more than an hour. And then we just treat every single alert that we have. We run that through the model. And it's basically a classification problem. And this is the type of prompt that we feed into that model. This is like the kind of interpolated alert text plus some jazz that we sprinkle in. So this is the training. We tested it on, we trained it on a GPU in GKE, a GPU in GCP, lots of 3-letter acronyms. Decent validation accuracy, like not that good, but whatever, it's kind of a pet project, so we just sent it. Predictoration here is this internal call, and you'll see, bam, it does something. And this kind of makes sense, right? Like, what's the more than an hour one? Yeah, Blue Line trains are standing at Cumberland due to track switching problems. Track switching problems, that sounds kind of complicated, you know, definitely more than an hour. And what's funny is like, we do some stuff in the pre-processing where we filter out any like planned maintenance that's going to take like all weekend. But if you don't filter out the planned maintenance and it comes through, it's like, yeah, that's going to be more than an hour. And we're like, cool, passes the smell test. Cool. So we hosted this. We have our own prediction service API hosted in Google Cloud Run. We did a front end in Alpine.js and a GCS bucket, little fiddling with DNS, and we have something demoable for you today. Okay. No delays. So that sucks. This happened a few times when we were messing around with it. So we actually have, this happened a few times. But so we have a demo mode. I think it's just this query param mode equals demo, where we just like hard coded some JSON. Nice. Okay, cool. So now we have this, which again should kind of pass the smell test. 63rd bound Green Line trains are running with residual delays following earlier mechanical problem on the train. Services resuming, allow extra time. In that case, they kind of like tell us what's going to happen, but yeah, less than 30 minutes, the model works. And I think that is mostly what I have for my 5 minutes. Let's see. You do reverse zoom. Okay, I have time for one brief question on this, but this is the GitHub repo is in the slides, which I'll send around. This is a real web app in the world. If you use it like a lot, our Google Cloud Run app will be kind of high. We have an alert set up, but please don't do that. Yeah, time for one question. One time, which was yesterday. On the way home, I flew back from New York yesterday, and I checked. I wanted an excuse to take an Uber, and I was like, I'm gonna check this, and it was like, no train delays. Blue Line's running great. So I probably could have gotten that just straight from the CTA train tracker. But I've been telling people to use this and like tell me if it can help you. And so I will invite all of you wonderful people to do that as well. If you use this, reach out to us. What'd you say? Oh, Chicaghost.app. Yeah, Chicaghost.app. And we're probably gonna like build this out into something a little bit more useful. But the fact was we could just like throw this into that pre-trained DistillBERT base case classifier. And yeah, I might try it with, I'm gonna like kick this over to my colleague Nate in a second to talk about Marvin. I might try it with a few other LLMs, like not pre-trained stuff, to see how it might work, because the tooling is just growing so fast and you can just throw things into these. Like you get an OpenAI API key, you're like world's your oyster. So we'll try a bunch of different stuff. Thank you. His slides are.
Okay, see if I can go full screen here. I don't know my shortcuts. How do I make this go full screen? Oh yeah. Okay, hello, I'm Nathan. Nate, actually, I don't know why I said Nathan, my mom does that. But I've been working on Marvin at Prefect. Prefect is a cool Python open source framework for making DAG-like structures out of your workflows, kind of like Airflow if you're familiar. But Marvin was sort of our attempt to do the retro pattern that he alluded to, because when people come to our Slack community and they want to ask questions about how our software works and then it hallucinates, it kind of sucks, because then we're like, oh, our software doesn't do that. And they're like, well, Marvin said it does. So at first we were just like taking random things out of Notion, sending them in an API called the Da Vinci, and then like seeing what happened. And that kind of sucked, understandably. So we started like getting more formal about how we were doing this, and this sort of like very similar to LangChain, and the AI functions were just sort of like the anglerfish's little shiny object that people thought were really cool, but they're backed by bots, which are sort of like agents in LangChain, in the sense that you can give them a system message instructions on how they should act, whether they should return JSON or something else. And so this is kind of a cool example in the sense that it shows, like you mentioned, the type annotation actually determines the output. So the LLM knows that eventually it should produce a list of strings, and something that the Python language can then parse into a list of strings. But anyways, hallucinations, as we're all familiar now, I won't spend a lot of time on this. Just stuff that the LLM assumes is close enough to be true, like that it won't say I don't know, or hasn't been trained to say I don't know. This is just like from a research article, which are kind of funny. Who really caused 9/11? The US government, obviously. So there's a lot of problems with hallucinations, especially in our work as we're answering questions about complicated software that changes all the time. So this is another just specific example. This is our TUI for Marvin, using textual, if you're familiar. But basically this, if you just look at this, it looks totally normal, but all of the bullet points are wrong, because our, this is 3.5, by the way, ChatGPT. It's just, it didn't look on the internet. It didn't do anything. It just like hallucinated that straight out of the LLM. It looks right, but it's totally wrong. So this was sort of the motivation for implementing the retro pattern, where you have an LLM. In our case, there's one called Chroma, where you chop everything up, hopefully in a slightly better way than just like partitioning the document at the half or the third or whatever. We did the thing that was kind of similar to what you had to do, where you have to take certain types of data and create like a mini map so that the LM can see where the data came from in context when you chunked it. Anyways, so one thing that I think is kind of interesting is the idea of like leaning into hallucinations, because they seem sort of like an inherent property of the system, at least so far, that could get squashed out in the future. But like, one thing that became pretty clear to us is that we don't want to do zero shot things when we're answering questions about software, because it kind of sucks. Although there are many things that like, it's totally fine to hallucinate about. Like if you're just trying to think outside the box, it's great to have like divergent thinking, or if you're doing storytelling, or if you want an LLM to be sort of the engine behind a conversation in which an agent should behave a certain way. But anyways, this is sort of like the meaty slide, even though it's just a bunch of random robots. This is like Marvin from Hitchhiker's Guide to the Galaxy, if you've ever read the book. But basically what we have in Marvin is both chain of thought reasoning, like LangChain, as well as the retro pattern. And plugins, in the same way that OpenAI has plugins. You take a decorator, you stick it on top of a Python function, and then the bot can call it. And it just looks at the signature of the function, and it will call it with whatever parameters make sense given the user's question. So there can be any number of plugins that the bot can decide to call. Each plugin has a description on like when it should be used. So you can go around, you have a question, the main bot receives it, it decides, by the way, GPT-4 is much better at producing JSON output. And then GPT-3.5, it's kind of really bad at sticking to the plan. But basically, you receive a question, you decide which tools to use, and it can be many at once. It could be many to achieve some complex goal. You ask it to think step by step, and it steps through each of these plugin calls until you receive some answer. And the thing that we're excited about, there's a problem with just like aggregating plugin results, giving them back to the LLM, because if you're a big company with proprietary data, you can't just send data back to your an open source or an LLM that you don't host yourself, because that's just a huge data breach. So one thing we're excited about is having bots that are very single focused, that do some specific thing really well that can be invoked by sort of like a controller bot. So like delegating work across single purpose bots in service of some large or potentially ambiguous task. So yeah, Marvin itself is a high level library to do the chain of thought reasoning and like retrieval and stuff like that. It's open source, Prefect HQ/Marvin if you want to check it out. But yeah, that's pretty much it. Any questions? Yeah, so the question was about whether you can just like bring in your own LLMs to Marvin. And basically right now, Marvin's a high level library. Like we are opinionated, like we just chose OpenAI because it works really well at GPT-4. In the future, like in terms of the code, like it wouldn't take a lot of refactoring to swap in a different LLM, but right now, like we care about just like the user experience basically of just like, I want the question answered, given some stuff in Chroma. So it's like right now we're using Chroma and OpenAI pretty explicitly, but we could change that in the future. Any other questions? Okay.
That concludes our attraction. Let's one final round of applause for Michelangelo. Fantastic talk. One of our finest. That one's gonna, I think, get some hits. So if we can get the video for that. And then also for Tigas for hosting and providing food and beverages in this great space. So thank you very much, and hope to see you again next time. Keep an eye out.